So we have domain and range on page 2 of your linear functions booklet. So for this, remember our domain is going to be the x values. Domain are the elements that are present. In functions, they are all the independent x values listed in chronological order, reading left to right on a graph where the function is defined. So we have bananas and strawberries. This would be a discrete example, and our domain would be the set bananas and then strawberries. Notice you don't have to actually write in strawberries, 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 and so on. You only have to say each thing once. Now for the graph that is on your right, we are going to label some points. Notice that the graph keeps going, so you can write an arrow. Arrows represent either left and right and up or down. In this example, the arrow is pointing to the left and going down. So your x value in this case would be negative infinity. And the y value would also be negative infinity because it's going down. We're going to plot this hole right here. The coordinate point for that would be -1, 0. And then we have another arrow. We'll circle it. It's going to the right and down. So we're going to say that is positive infinity because it's going to the right, and then negative infinity because it's going down. Using this, we can write our domain in interval notation and set builder notation. So our domain in set builder notation would be braces x such that x is an element of all real numbers. And then for interval notation, our domain, we look at the left value, which is negative infinity. Arrows and holes are always open, so you put open parenthesis. And then we stop where we see a hole, and that's at x equals -1. The union, -1, and then we keep going until we get to the rightmost x value, which is positive infinity. That would be our domain in interval notation. So the range are the elements that are present because of the domain. In functions, they are all the dependent y values listed in chronological order, reading down to up on a graph, where an output is produced from inputting a domain value. So if you look at this example, we're reading from down to up. So then we have squirrel first. So our range would be squirrel, and then fox, pig, and then at the top, our maximum value would be the cat. And you close your brace. So this is a discrete example. Now let's look at the graph. Well, this is almost the same graph as before, except for the holes been filled in. So you want to label your arrows just like before. You're going left and down. So it's negative infinity and negative infinity for both your x and y values. We're going to label our maximum value. That's the highest point on this graph. 1, 4. And then we're going to label our other arrow. It's going right and down. So it's going to be positive infinity and negative infinity. So using these, we can write out our set builder notation and our interval notation. So R is Y such that Y is less than or equal to 4. Now you could put the negative infinity as less than right here. But besides interval notation, you do not have to put the negative and positive infinity symbols. Now for interval notation, you would write those infinities. So our lowest value for y is negative infinity. So we have negative infinity, 4. And the 4 is included because we have a closed point. So we're going to put a bracket instead of a parenthesis. So as you can see, there are multiple notations to give the domain and range. There's set builder notation, inequality notation, which is just the stuff inside of set builder notation in a lot of cases, and interval notation, this one. So we have open intervals. We have these kind of symbols, the less than symbol, open parentheses, and greater than. We have dashed lines, holes, arrows, and infinity symbols. Those are unbounded. And then we have closed intervals, and we have these kind of symbols. The less than or equal to sign, closed brackets, greater than or equal to, minimum points, closed points in general, a solid line, maximums are highest points. These are all bounded, so those are included in the set.